I would like to talk about QA management at Exactpro. A little bit about me. I am co-CEO of Exactpro Systems LLC. We started the company with my friend Iosif 7 years ago. My experience includes software developments on C++ and Java and .NET, and a lot of QA management in different companies. Today I would like to discuss the topic of QA management. We will talk about fundamental principles of QA management as we see them at Exactpro. We will describe something that we call anti-patterns. And at the end of the presentation, there will be a little summary and comparison between anti-patterns of QA management and our principles. So let's move to the fundamental principle of QA management. It's actually very, very simple stuff. QA is a learning. So we learn how a system should behave in production. We learn how system actually behaves, how under the tests, and we compare. Everything is targeted on this task. So as a second part of the job, we develop test design. We're trying to come up with ideas how to do learning more efficient. We come up with test tools and automated test libraries. And this is a permanent process. We not learn in the beginning and test at the end. We constantly learn. And we learn even when system goes into production and we receive feedback from productions, we learn as well. Now let's discuss anti-patterns. These are some QA management techniques that, in our opinion, actually that lead to inefficient QA. Just a little bit, just a few words. I'm not saying that test automation or the test library is itself a bad thing. I'm saying that using these anti-patterns will lead to inefficiencies. So let's move to the first anti-patterns, the requirements traceability matrix. This is an attempt to base all testing on the requirements. This is a formal approach. When in the beginning of the project, we write the requirements, and then we develop test cases by just copying these test requirements. In our experience, such approach leads to the very limited test coverage, and the testing and the test team only as good as the requirements are. And basically, in this case, testers only do what they told to do in the test requirements and do not add any value. The next anti-pattern is test automation. This is an attempt to automate a full regression library. So somebody says that we must automate everything. We need to do complete regression in the night builds. The change is the part of software development process. So if we try to script all test requirements or all test scenarios and automate them, we will fail because software constantly changes. There are new requirements, there are bugs and issues, there are changes of software development directions, and if we need to redo test automation every time there is a change, we end up spending a lot of effort in maintaining such test automation as automated test library. So the possible outcome of this anti-pattern is that a lot of effort and resources wasted on test automation, and you will not have the outcome you want to achieve by the test automation. Okay. The next anti-pattern is the test library. This is an attempt to document all test cases in detail before actually start testing. This is, as you can see, this gives us a lot of paperwork, and when we try to do this, we have limited number of key resources that could spend the time on testing, just writing test scenarios step by step. And in the end, you have very limited test library because you are only as good as many typewriters you have in your test teams. So, using this pattern, you will end up working on documents, not on the testing. The next anti-pattern is the test plan. This is an attempt to draw a big Gantt chart, putting all QA activities there, and then try to follow this Gantt chart and to try to work very hard to achieve milestones and objectives of this Gantt chart. This will not work because we have been dealing with unknown from the beginning to the end of the project. We never have the situation when we can predict what will happen next, because the testing is partly the research and finding bugs. Depending on how many bugs we find, on how many issues we will discover, and depending on a lot of other things, it constantly changes. So we need to use agile modes, not the waterfall. The next anti-pattern is non-functional testing. This happens quite often. Company decides to do non-functional testing of the software. They allocate hardware, production-like hardware, and they do load testing. They do load testing. They measure latency. They measure capacity, and that's it. They do not try to test system on the load. They just try to measure KPIs, performance KPIs. This leads to the fact that vast area of test conditions is not covered. So you will see problems like, I don't know, something like race conditions or other load-related functional issues in production. The next anti-pattern is the test tool. This is an attempt of using the commercially advertised test tools. There is nothing wrong with these test tools, and they add a lot of value in many of QA teams, but in our world of trading and clearing and settlement systems, those tools do not add a lot of value because they are mostly targeted on UI, and UI is only a very tiny piece of our universe. And actually, what usually happens with these test tools, the QA team spends a lot of time of trying to deal with limitations of such test tools and to test the system anyway, despite of these tools, not because they have tools they have to deal with, not because they need to solve some specific problem. And the last anti-pattern from my list is the Scrum team. This is an attempt to blend all QA in this development Scrum team. So we say that testing should be done by developers or by testers and Scrum team, and everything that comes out of that doesn't require any testing. I believe that this approach probably will work in the world of Google or other startups, but in market infrastructure systems, we actually need integration QA very badly. And if we will not do the integration testing and we will not put the team of people who understand the business requirements and the infrastructure and not let them test the system, use their critical judgment, we will have a lot of issues in production. So these are anti-patterns that I want to use to illustrate our key principles. So on the last slide, I will briefly describe the comparison of the anti-patterns and our test principles. First of all, developing the team knowledge versus the requirement traceability matrix. So we learn a lot, and our test coverage not defined by the spreadsheet and with links to the requirements, but the actual knowledge of our people who test the system. The next principle is building software, test software versus test automation. We develop test tools for efficient regression, and we assume that there will be software changes in the systems that we are going to test. So we design our test tools carefully to make sure that these changes will not will not draw us to constant rebuilding our test tools. The third one is test design versus the test library. We develop test design, which is our approach to testing. We put a lot of our analytical effort to come up with efficient way of doing tests and to increase coverage and decrease effort. Number 4, agile iterative approach versus the test plan. So yeah, we're using agile development techniques in testing to be flexible and to deliver the systems that we are testing to production. Number 5 is testing at the confluence of functional and non-functional testing versus non-functional testing. So we not only do non-functional testing in classical way, but we are spending a lot of time trying to test system under the load. We develop corresponding test tools. We use post-transaction analysis and other stuff. Number 6 is pragmatic in-house software development of test tools versus the test tools. So we develop our own test tools based on our tasks and our obstacles. We're not buying any third-party software test tool. And the 7th principle is QA is a pacemaker versus the Scrum team. This is the idea and what's usually happens. So when we start testing the system, we raise so many issues and try to turn around these issues so fast that development team have to follow us by fixing these issues. And this way we usually drive the development process of the system that we are testing. So that's basically it about our software management principles. So if you have any questions, feel free. Yeah, Jerry?
Yeah, Alexey. Obviously, one of the things that management and kind of business people like about the traditional kind of methods of traceability metrics and non-functional KRIs and all that stuff is it provides some tangibility to what to them sometimes is just technology concepts and all that. So how do you put metrics and quantify some of these kind of softer approaches you're talking about to how are you able to kind of report on those to provide that confidence to management that things are going well and things are in control?
Basically, what Chris mentioned earlier in LSEG, we have come up with quality metrics in LSEG. And the main lagging indicator for quality metrics is the number of issues leaked in production. If there are many issues in production, then we are doing a bad job. If there are few issues in production, we'll do better, but not ideal. If there are no issues in production, that we are doing a good job. So this is a lagging indicator. And leading indicator, basically we measure the test coverage. So basically you have two parameters. First parameter is how much money and how much time do you spend on testing. So the less you do it, the better. And another is the test coverage you provide. And the measurement of the test coverage, there are a lot of measurements. First of all, you can, just by talking to software of QA people, business people can feel what they know about the system, and what they test in the system. So you can just query them. Other way is they just do the presentation and present their knowledge and their test design in the format that is convenient for them to explain the test coverage. The other way to approach it is using, I don't know, coverage analysis tools. So we can run our regression library in front of the code coverage analysis tool, and those tools can say, yes, this test library covers, I don't know, 80% of the code. And we're doing this with our work with Millennium. So there are a lot of ways to measure it instead of just producing this test library and documentations, in our view.
When you were presenting the anti-patterns, you mentioned about the test automation that can't be 100%.
Mm-hmm.
Okay, my question is how much percentage you think is reasonable in terms of automation?
Well, it depends on the project, on the complexity, on the endpoint to the system, on how many third-party system is connected to, on how volatile the environment around the system. Basically, I think that we can cover a fair amount of percentage in automated or semi-automated tests. We just do it our own way by developing a test tool that allows us to achieve this. It may be not just some tool that simulates test scenarios step by step, send order, receive execution report, receive market data, etc., etc. Sometimes it's a load injector with random load. Sometimes it's post-transactional tool. Sometimes and with analysis of local and transactions happening in the system. So basically, I can't tell you the number. Nobody can. But in our work, we aim to achieve something close to 80 to 70% of of automated tests versus of manual testing. But again, this is happening only for regression. If you are doing functional testing, so you're dealing with software change, you have to spend a lot of effort in learning process, and usually it's manual process. It's process of getting to know the system and to understand how it works, etc., etc. Okay. If there are no more questions, I would like to pass the floor to the next speaker, which will be Selfish.